So recall that the equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk is a point, and hk is the center, and r is my radius. So what I'm going to be doing for numbers 1 through 4 is plugging into this equation. So at my center, this is going to be hk, this is going to be my r. I'm going to plug into the formula, so I'm going to have x minus, from the formula, negative 3 from my point, squared, plus y minus 4, because it's my k value, squared, equals 7 squared. So then what I want to do is I just want to go ahead and simplify. I have a double negative right here, so that's going to become positive. And then my y term stays the same. And then I just want to square the 7, which gives me 49. So same thing on number 2. I have my h and my k and my my r. So what I want to go ahead and do is plug in. I'm going to have x minus negative 9 squared plus y minus 0 squared equals 10 squared. So then what I want to do is simplify the inside, so double negative turns into a positive. On my y1, I have y minus 0, so anything minus 0 is just y. So I can write this as y squared without the parentheses. And then 10 squared is 100. So this is my final form of that equation. On numbers 3 and 4, I need to find the center and the radius for myself. So my center is right here. And it's kind of hard to see on the copy I printed out where my axes are. So I'll highlight them. So this center is right 3 down 2. And my radius is the distance from the center to one of the edges, so I can count either side, to either side, or up and down. I'm going 1, 2, 3, 4, 5 squares over. So I want to plug those two in. Remember, my center is hk, my radius is r. So I'm going to have x minus 3 squared plus y minus negative 2 squared equals 5 squared. And then I need to simplify anything on the inside. So my x1 is fine. On my y, I have a double negative, so that's going to become a plus. And then 5 squared is 25. I want to do the same thing for number 4. So it's going 1 to the left, 3 down. And my radius here is from the center to one of the edges. 1, 2, 3, 4. So this is my hk and my r. I'm going to plug into my circle formula. So I'm going to have x minus negative 1 squared plus y minus negative 3 squared equals 4 squared. And then I want to simplify. X minus 1 is the same thing as adding 1. Y minus negative 3 is the same thing as adding 3. And 4 squared is 16. Moving on, numbers 5 and 6 want me to plug in my points to see which one goes into the circle. So I'm going to plug them all into the formula for x and y. First one, I'm going to have 6 minus 6 squared plus 9 minus 4 squared, and see if this equals 25. 6 minus 6 is 0. 9 minus 4 is 5. I happened to get the right answer on my first try, because 0 squared is 0, 5 squared is 25. This one is my answer. And I'm going to do the same thing on for number 6. So this is my x and y. I'm going to plug them in. So I'm going to have negative 12 plus 4 squared plus y, nope, not y, 0 plus 3 squared, because I'm plugging in for y, equals 64. Negative 12 minus 4 is negative 8. 0 plus 3 is 3, and this should equal 64. Negative 8 squared is 64. 3 squared is 9. 64 plus 9 does not equal 64. So my first answer is not it. Then I want to plug into the second one. I have negative 4 plus 4 squared plus negative 11 plus 3 squared equals 64. Negative 4 plus 4 gives me 0 squared. Negative 11 plus 3 gives me negative 8. Should equal 64. 0 squared is 0. Negative 8 squared is 64. 0 plus 64 is 64. So B is my answer, and I don't need to go any further. Number 7 is asking what transformation proves that all circles are similar. This one is a dilation, because remember, they are all just growing or shrinking from each other. All of the angle measurements are preserved. Moving on, this one gives me a diagram and it wants me to describe the parts of the circle. So it wants me to say what JE is. JE is right here. This is going out from the center to the edge, so this is a radius. Then I have KH, which is going edge to edge, not through the center. This one is a chord. I have CF, which is a line that goes on forever, and it touches the circle at one point. This one is called a tangent. Then I have KG, so KG goes straight through the center from edge to edge of the circle. This one is a diameter. And the final line I need to look at is FH. Let's do pink. So this one is a line that goes on forever, that goes through my circle. This one is a secant. Numbers 9 and 10 are looking at inscribed angles. So if I'm going from my large angle to my small angle, I want to divide by 2. I'm going to go from 84 and divide by 2, which gives me 42 degrees. When I'm going from the inside to the arc, I want to multiply by 2. So I'm going to do 67 times 2, which I'm going to do by hand for some reason. I have 2 times 7, which gives me 14, 2 times 6, which gives me 13, so my answer here is 134. – 12 and 7 are still using my inscribed angles, but now I have an equation. So to go from small to big, I want to remember to multiply by 2. So I'm going to write my equation. I'm going to have 2 times 31x plus 3 equals 192. Then I want to go ahead and distribute. 2 times 31 is 62. 2 times 3 is 6, equals 192. I want to subtract 6 on both sides. This gets me 62x equals 186. Then I want to go ahead and divide both sides by 62. So I am going to use the Desmos calculator on my phone. I'm going to type in 186, divide by, 62, which gets me x equals 3. So Same thing for number 12, except this time, when I go to multiply by 2, I know my inside, and I'm going to my larger. So I'm going to have 2 times 67 equals 16x minus 10. So 2 times 67 is what I did up above. So I know that is 134 equals 16x minus 10. Then I want to go ahead and add 10 to both sides. I get 144 equals 16x. I want to go ahead and divide both sides by 16. Which gets me 9. Moving on. This one gives me a picture and tells me that the measure of angle B is 72, and then I need to find the measure of angle D. So if I take a look, this is angle B, and the measure, and angle D is this angle right here. Notice they are both going to the same arc right here. So if B is 72, then D is also going to be 72. Whenever two angles share the same arc, they give you the same angle measure. So I'm going to take a look at number 14. It tells me the measure of angle C, so this angle. And then it wants me to find the measure of angle D, this angle. So if I know this one is 65, the other one is also going to be 65, because they share that arc. Numbers 15 and 16 want me to find the measure of each arc. It wants me to first start off with EF, so this one right here. The way I can do this is I see that EB is a diameter, and I know my measure of FB is 60. So what I'm going to do is I'm going to do 180 minus 60, which gets me 120 for this angle right here. Then I need to find the measure of ED, which is this measure right here. So what I'm going to do is I am going to, like I said, EB is a straight line. I know that this is 52, and remember the square box means 90. So I'm going to take 180 and subtract 52 and 90 to get my arc measure for ED. So I'm going to pull out my phone again and use Desmos. I'm going to do 180 minus 52 minus 90, which gets me 38. Then for my final part, I want to find the measure of angle FCD, which is those three angles that I've just highlighted. So I can go ahead and add those together. I'm going to add 90, 52, and 60. Which gets me 202 degrees. Number 16 also wants me to find the measure of each arc length. So the first one it wants me to find is AB, which right here, if I take a look at this, AB and EB are both diameters of the circle, which makes AB vertical angles with ED. So this is just going to be 55 degrees by vertical angles, because they are across from each other. Next one I have is BC. This one makes a right angle with AB. So I am going to do 90 minus the 55 I know goes for AB. So I just need to pull my calculator out. which gets me 35 degrees. My final arc length it wants me to find is BED. So this is this. I have that ED is 55, and remember EB is a straight across line, so this whole part from here to here is 180. All I need to do to get BED is add 180 to 55. This gets me 235. So my final two questions just want me to list all of my central angles. What a central angle is an angle that goes through the center. So I just need to list all of them. On number 14, I have this one right here, NPM. I have this one right here, MPL. I have this flat line, NPL. And that is it for my angles that go through that center. Because if I do from here to here, that's also NPL. If I take a look at number 18, I have this angle, so angle QOT. I have this angle, angle TOP. And then I also have the straight line, angle QOP. Those are all of my central angles on this diagram.